Okay, I'm going to go ahead and get started since it's 10 o'clock. What we're going to be doing section 8.2 today, which is going over, there's different characteristics of all polynomial functions. Okay, the first thing we're going to talk about is what's called the maximum number of zeros and x-intercepts. Remember, these two words are interchangeable, right? They mean the same thing. Your x-intercepts and your zeros mean the same thing. They both mean where the graph crosses or touches the x-axis. When you're, say this is the graph that you're talking about. The maximum number of zeros and x-intercepts is whatever your highest exponent is, which means it would be 5, which would tell me the maximum number of zeros that the graph can have, which is also the maximum number of x-intercepts that the graph can have. So the maximum number of times that if I put this in my y equals on my graph, the maximum number of times it could cross through or touch the x-axis would be 5. Now, the maximum number of turning points is whatever the highest exponent is, minus 1, which means the maximum number of turning points this graph would have, and turning points are these points right here where the graph turns around, right? It turns here. Turns here, turns here. The maximum number of turning points that this graph would have would be the highest exponent minus 1, which means it would only be able to at most have 5. So let's look. I'm going to bring this board. Let's look at a graph that we are all familiar with, and let's see what this means. The x squared graph is a parabola, right? It's that U shape. So let's look at these two ideas with an x squared graph. So if I'm an x squared graph, my highest exponent would be 2, which would tell me what? The maximum number of x-intercepts would be 2. And the maximum number of turning points would be 1. So I'm going to draw 3 separate x squared graphs up here. So I have 3 different x squared graphs up here, right? They're all x squared because they're all parabolas. They're going in different directions and they're in different spots. But they're all x squared. So let's think about that rule. So since they're all x squared graphs, the maximum number of x-intercepts should be 2, right? Well, how many x-intercepts does this graph have? If this is my x-axis, it crosses it once here and once here, which means it has 2 x-intercepts. Again, here's my x-axis. How many times does this one cross or touch the x-axis? Just right there. So it only has 1 x-intercept. What about this one? How many times does it cross the x-axis? Well, here's my x-axis. If it's a parabola and it's upside down, and it doesn't go high enough to cross the x-axis, and this one has 0 x-intercepts, right? So a x squared graph can either have 2 x-intercepts like this example, 1 x-intercept like that one, or no x-intercepts like this one. Is there any possibility, if you are a parabola, to have 3 x-intercepts? What would that mean? That would mean that your U would have to cross through the x-axis 3 times. Is there any way a U shape is going to cross through this x-axis 3 times? There's no way that's going to happen, right? What would have to happen? This graph, if I'm going to cross through the x-axis again, what would have to happen? This would have to turn back around and come back down and cross the x-axis a 3rd time. But now, look at your graph. Is it a parabola anymore? It's not a parabola anymore, which means it's not an x-squared graph. Okay? So that's why that rule that says whatever your highest exponent is going to tell you the maximum number of x-intercepts. What about turning points? What did the turning point rule tell me? It says whatever the highest exponent is, minus 1 is going to be the maximum number of turning points of the graph. Which means if these are all x squareds, none of them should have more than 1 turning point, right? Because that would be the highest exponent minus 1, would be 1. Well, how many turning points is here? Just 1, right? It turns right here. Here. It turns right here. It just has 1 turning point. What about this one? 1 turning point. What would have to happen to any of those graphs for them to have a second turning point? Well, I'd have to turn again, right? I'd have to turn again. So if I'm going to have 2 turning points, am I an x-squared graph any longer? No, you're something else, right? X-squared graphs are just plain U's. They are parabolas. Okay? Let's look at the same situation with x to the 3rd graphs. And again, graphs that we've worked with before. I'm going to draw 2 different x to the 3rd graphs. So if I'm an x to the 3rd graph, what should be my maximum number of x-intercepts? Whatever the highest exponent is. If I'm x to the 3rd graph, my highest exponent is a 3. So let's see, how many x-intercepts does this one have? Just 1. How many x-intercepts does this graph have? It's got 1 here, 1 here, and 1 here. So it's got 3 x-intercepts. Which should be the maximum number of x-intercepts that an x-cubed graph should have, right? What would have to happen for this graph to cross through the x-axis again? I'd have to do what? I'd have to turn around here and come back up to cross through it again. What just happened? I did cross through the x-axis again, so now I've got 4 x-intercepts, but am I any longer an x-cubed graph? I'm not x cubed, I'm something else, right? Because x cubed graphs just they are that shape. So that's why the rule for maximum number of x-intercepts and maximum, oh, I didn't do the turning points. What were the maximum, where did these turn? Let's see, this one over here. X cubed graph should have no more than 2 turning points, right? Because how do you find the number of turning points? Whatever the highest exponent is, minus 1. Which means x cubed graph should have no more than 2 turning points. Let's see, it's easy to see on this one. Here's 1 turning point right here. Here's another turning point right here. So it's got 2 turning points. Is there any way for this shape of an x cubed graph to have another? No, because what would have to happen? It'd have to turn again to have another turning point, which makes it not an x cubed graph anymore. So that'll get you through the first 3 problems. All they're going to ask you on each one is, it'll give you a polynomial function written out. You'll look for the highest exponent. The highest exponent will tell you the maximum number of zeros and X intercepts, and then subtract 1 from that will tell you the maximum number of turning points. Now, 4 through the end, and I'm about to start sharing my screen here in a minute, and I'll give you this, because for the Zoom people, if I'm sharing my screen, they can see the worksheet, and you have the worksheet printed out, so that way we'll all be able to see it together, because it's a bunch of multiple choice graph situations, and I can't draw them all out. Okay, so I'm just gonna share the actual. Oh, do you have your laptop? Okay, then you can just bring it up. That'd be great. Okay, so I'll help you. So let's talk about the different characteristics. There's 2 different things you could do. Go to, when you Zoom, do you Zoom or do you just watch the recording? Do you have Zoom on your laptop? I don't see one on either. I think you could just go to zoom.com and okay, so the other thing that we're going to talk about, because what it's going to give us is that on number 4 through the end, it'll give us this polynomial function, which is polynomial is just a fancy way to say a group of terms. And then it's going to give you 3 or 4 graphs to choose from and says, which of these graphs matches this polynomial function? So let's talk about how the different characteristics that we're going to use from the function to see what that graph should be doing. And the first one we're going to talk about is the end behavior of the graph, right? The end behavior of the graph is what's happening at both ends of the graph. And we talked about this on the Friday lesson, the end behavior. And it has to do, again, with your leading term. And there's 4 situations that you could be. There's 2 types of even end behaviors and 2 types of odd end behaviors. If your highest exponent, let's see if this is an even. If your highest exponent is 4, that means your end behavior is even, right? Your highest exponent is 4. That's what you're looking at for the end behavior. If your exponent is even, that tells you that the ends of your graph are both going in the same direction. Either both up or both down. So that's both even. Now, to tell whether they're going up or down is whether or not the term is positive or negative. So if you are even and positive, your end behavior, the ends of your graph are both going to be going up. So that's what that one will be, right? Even, positive, both going up. If you are even but negative, again, the ends of your graph are going to be going in the same direction as each other. But what if you are negative x squared minus 6? So again, I'm even, but this time I'm negative. So my ends are still going to be going the same direction as each other, but this time they would both be going down. Right? Because what does this do? Flips your graph upside down. That's what makes the ends both go down instead of both go up. Odd behavior tells you that my ends don't match each other. They don't go in the same direction as each other. You're going to have one up and one down. If you are even and positive, like x to the 3rd plus 7. So again, Did I say even? I meant odd. My exponent's odd, and I'm positive. That means you are traveling up throughout the graph. So the easiest thing to do is think that your left side is going down, certain things are happening in the middle of the graph, and then your right side is going up. All kinds of things can happen in here. Oh, I forgot to write positive. So again, odd and positive would mean you start at the bottom, you do all kinds of things, and then you end up at the other end going up. Odd and negative. So if you were negative x cubed plus 5, so I'm still odd, but this time my leading term is negative. That means your graph starts off going up, travels down throughout the graph. So those are the 4 types of end behavior. Again, even and positive, both up. Even and negative, both down. Odd and positive, during the graph, you are traveling up, which means you start at the bottom, your graph starts with a down arrow and then travels to an up arrow. Odd and negative is the opposite of that. Starts at the top arrow, and then throughout the graph, it travels down. So those are the different kinds of end behavior. Now, let's talk about Y and X intercepts. Again, I'm just trying to give you all the knowledge that you will need to work through the last problems on this section. So if your graph or if your function is written out as the polynomial, which is the group of terms. So let's say like that. So your polynomial sometimes will be written out like that, or sometimes it will be written out in its factored form, like this. If I am written out as unfactored, my group of terms are listed out like that, the easiest other distinguishing factor to find is the Y-intercept of the graph. Because the Y-intercept occurs when the x is 0, which means if you went in and replaced all of the x's in this polynomial function with zeros, what's going to be left over? I'm going to just write it out. I would have 0 to the third plus 6 times 0 squared plus 7 times 0 minus 17. What happens to all this? These terms right here. Since they all have a 0 in them and I'm multiplying, this all right here knocks out, right? 0 is all 0, which means what's left over? The term at the end, or wherever it is, that doesn't have an x, that is your Y-intercept. That's going to tell you where your graph will cross through the y-axis. So that's another distinguishing feature of the graph. Okay? Now let's talk about if your function is not written out as the polynomial with the group of terms all listed out, but it's written out in factored form. This goes back to Friday. I I'm going to find the X-intercepts because it's already in factored form for me. Remember how we did this on Friday is you set each factor equal to 0, solve them for X, which means here I would have to subtract 1 from both sides. So here, X would equal -1. Here I'd have to add 7 to both sides. So X would equal 7. What did that tell me? That told me where the graph crosses or touches the X-axis. So the X-intercepts would be 7 and -1, which means if I'm looking at the graph, it should cross or touch, depending on its multiplicity. We won't get back into that, but it's going to cross or touch the X-axis at -1 and +7. Okay, now I'm going to start sharing my screen. So you can just look at your printed out sheet. Yeah, so I'm going to go through, I'm going to start with number 4. So you can, is yours touch screen? So you can make it big if you need to. Okay, good. That's all you need to be able to do. Okay, so I'm going to start sharing my screen and looking at this homework sheet. And we're going to use all the information that we just talked about with in behavior, X-intercepts, and Y-intercepts to match these graphs to their function. I'm going to go to A2. Oh, that's not what I want to do. Hang on. Course content. We're in week 8 now. 8-2 handout. Okay. All right, down to number 4. So the function on number 4 is 1/4 x squared minus 4. So the first thing you're always going to look for is the end behavior. So looking at this graph, this function, what should my end behavior be? If I'm 1/4 x squared minus 4, what's my exponent, my highest exponent? 2. So it's an even end behavior, right? Which tells you what? Even end behavior either means both up or both down. They just have to be the same as each other. And what tells us whether they're up or down is the sign. Is this a positive x squared term or a negative x squared term? It's positive, right? Because it doesn't have a negative in front of it, so it's positive. Which means the ends of the graph are both going to go up. So look, that's all I need to know actually to find this graph, right? What does A's do? They both go up. What does B's? Both do the same, but they're going down. So it's not B. C and D have one going up and one going down. So those are odd in behavior. So the only thing that matches both up would be A. Okay? Now let's talk about Y-intercept on this one. look at A's y-intercept. Where does it cross through the y-axis? Well, if you're looking at it, look at your function. What if I replace that x in the function with a 0? What would be left over? -4, right? If I were to put the 0 in that spot right here with the x squared, it just knocks out that whole term. So all I'm left with is -4, which is y-intercept. And look at where it crosses the y, right here on the y-axis at -4. So that would be another distinguishing feature. For instance, if I had two graphs where the in behavior were both up, then something else you could look for would be the y-intercept. I just didn't need to do it on that one. All right, number 5. My function is x to the 5th minus x to the 4th plus x squared plus 6. So my leading term is x to the 5th, which means the exponent is 5, which is odd, which means if your leading term's exponent is odd, you're going to have a 1 up, 1 down situation, right? That tells you they're not going in the same direction. One's up and one's down, which means it's not B, right? B's are both going down. So now, what am I talking about? Let's see. A's starts at the bottom and travels up. C's starts at the top and travels down. So what is x to the 5th? Is it a positive term or a negative term? It's a positive term, right? Which means what should your graph do? It should start at the bottom and throughout the graph, it should go up. Who does that? A or C? Well, look at A. Starts down here at the bottom, travels up throughout the graph. So that's why it would be A, correct? All right, let's look at number 7. This one I'm going to have to use a little bit more information because let's start off with our leading term. Let's see how far that gets us. If I'm doing leading term on A, or not A, let's look at what should the leading term tell us? The end behavior. So it's x to the 4th, right? Which means my exponent is even, which means both up or both down. What kind of term is this, positive or negative? It's positive, which means both ends of the graph should go up. Well, that means A is out, but B and C are still in, right? Those both go up. So now I'm going to go after that, since it didn't narrow it all the way down to one graph. I got to choose either B or C. I'm going to go with my y-intercept. So let's see, if you replaced all of the x's in this group of terms, what's going to be left over if I replaced all those x's with zeros? That -20. So let's look at B and C and compare them. Now, also, I noticed down here where that little bit of information they give you at the bottom of the graphs, look at the end of that. It says x scale equals 1 and y scale equals 10. X scale being 1 just means your x-axis hash points, hash marks are going by 1s. Y scale means that each hash mark on the y-axis is going by 10s. So this is 10, 20, 30, 40, 50, 60, 70. And below the origin would be -10, -20. You see what I'm saying? So you need to know what that scale right there at the bottom first. So the Y scale means each hash mark goes by 10. So remember where it's supposed to cross through the y-axis, since it's my -20 is what I'm looking for. Well, there's -10, negative 20. So B does cross through the y-axis at negative 20. Where does C cross through? At that first hash mark, which would be negative 10. So that's why you would choose B. So you had to, after the leading term in behavior, then you had to go to your y-intercept to pick between the two that were still left. All right, number 7. Negative x to the 5th minus 3x to the 4th. So my highest exponent is 5, which means 1 up, 1 down, right? Since it's odd, which is good, that means it's not A or B, right? Those both have even function in behaviors. Now, let's see, what's the other thing I talk about within behavior, whether it's positive or negative? Well, this one's negative, which means I have 1 up, 1 down. Let's see, if it's negative, that means you're going to start at the top and travel down during the graph. So we're only left with C and D. Look at what C does. Starts at the top, travels down like it's supposed to. Look at D. What does D do? It starts at the bottom and travels up. So which one should it be? C, right? I want to start at the top and travel down. Number 8. In behavior, my highest exponent is a 6. So that's even. Either both up or both down, which is good. That means it's not B or C. Is my in behavior positive or negative? Well, x to the 6 is a positive in behavior, right? Which means what should happen at both ends of the graph? They should both be going up. If you are even and positive, you're both going to go up, which would be D. All kinds of weird stuff is happening in the middle of this graph, right? There's all kinds of turning points and X intercepts and things like that. But if I can tell that both ends are going up at the end, like they are on D, that's the only graph that matches the in behavior of a positive even in behavior. All right, number 9. If you're going to use in behavior, so look at the difference between 9 and 8, what was given to us. On 8, you had it written out as the group of terms, right? X to the 6 minus 4x to the 4th. Look at number 9. It doesn't give you the group of terms to give you the lead information. It gives you the factors, right? They're in its factors. So if I'm going to use leading term to determine my in behavior, I have to act like all those factors are multiplied or FOILed together to see what my highest exponent would be. So if I was going to multiply all these x and x minus 2 and x plus 4 and x minus 6 together to find out what your leading term would be, all you have to do is count the x's. So how much x do I have? I've got 1, 2, 3, 4, which means if I multiplied all that together, my leading term would be x to the 4th power. So what does that tell me about the graph? My exponent would be even and positive, right? It's only going to be negative if this x out here was negative or one of these x's in here was negative. There's nothing that's going to turn my x's negative if I multiplied that all together, which means it's going to be positive and even, which means both up, right? So which ones of the graphs are both up? Luckily for us, let's see. This one is down and up, both down, down, and up. Look at the D, up and up. So the only one that has the in behavior that matches what it needs to be here is D. While we're on this one, let's go ahead and remember how I said if your, I know it's going to be hard to see. I'm going to write something big here in a minute. If your graph is written out in its factored form, instead of listing all the terms out, you see the factors in parentheses. What can I tell very simply from each one of those parentheses? The x-intercepts, right? So looking at this particular graph, what would the x-intercepts be? And if it's just x plus or x minus something in the graph, the x-intercept is just going to be whatever the opposite of that sign is, right? Because what happens when I set x plus 1 equal to 0 and solve it? It gave me x equals -1. So looking at these, this x, if I set it equal to 0, would give me 0. X minus 2 would give me x equals 2. X plus 4 would give me x equals -4. And x minus 6 would give me x equals 6. Well, let's look at D. Does it cross or touch the x-axis in those spots, which would be 0 for that first x? So let's see, down on D, does it cross the x-axis at 0? My cursor is on the 0 right now, so I do see it crosses the x now. There. X minus 2. So that would give me an x-intercept of +2. Before I do talk about that, let's look at what your x scale is. If it's 10 here at the end, but there's only 5 hash marks to get there, what does that mean each hash mark is? It means each hash mark is 2, right? They go by 2s. 2, 4, 6, 8, 10. Well, let's see. It should cross at x equals 2, which would be the first hash mark. Well, look, there's 2. And is there an x crossing there? Yes. What about this one? X equals -4. Let's see. There's -2. There's -4. Is there a crossing at -4? Yes. And this last one is at x equals +6. So let's come to this x-axis. And look. So 2, 4, 6. Is there a crossing at the 6? Yes. So you may at some point have to use that information also. All right, number 10. So remember the end behavior. On this last one, I just counted the x's. This one, I'm going to count the x's also, but if you have a parenthesis with an exponent outside of it, that means you count the x that's inside that parenthesis that amount of times. So both of these x's inside these parentheses count twice, right? So this would be 1x from this first x, 2 more x's from this x inside that first parentheses, and 2 more x's from that one. So how am I, if I foiled and multiplied those all together, I'd end up with some kind of x to the 5th power, right? There'd be 5 x's, which is an odd in behavior, which means 1 up, 1 down. 1 up, 1 down. The only thing that's helping me out there is it knocks out C, since C is both up. Now, is my end behavior positive or negative? Well, this negative right out here in front of my function tells me that it's negative, which means what should the ends of my graph do? They should start at the top and then throughout the graph travel down. Well, the only thing that helps me with is it knocks out A, right? Because A starts at the bottom and travels up. So I've knocked out from the end behavior only A and C. B and D both do what? They both start at the top, do some funny stuff, but end up going down. So I now need to look at the x-intercepts, right? Since it's written out in factored form. Where does this first x tell me the graph should cross or touch the x-axis? At 0. Well, it looks like it does that on B and D. So I need to move on. Look at that first parenthesis. Since it's x minus 1, where does that tell me that x-intercept is? It's at positive 1, right? Which means I should go to my x-axis and look at positive 1 and see if there's an x-intercept there. Well, let's look here. Here's on B. There's positive 1. Does it touch the graph there, or the x-axis there? It does. Look at D. D. There's positive 1. Does it touch there? No, it's not touching the x-axis at positive 1. What's the other x-intercept that we should look for? What's the other factor? X plus 2, which is also telling me that it should cross or touch the x-axis at negative 2. Look at B. There's negative 2. It does touch there. Look at D. Here's negative 2. Doesn't touch there. So B is the one that does everything it's supposed to, right? It's got the correct in behavior. It starts up, does weird stuff, travels down. It's also got x-intercepts at positive 1 and negative 2, like I get from these two factors. Okay? Number 11, 2 more. All right, let's see. Let's do in behavior. Let's see. How many x's is that first parenthesis going to give me? 2. How many x's is that second parenthesis going to give me? 4. So if I multiplied that all together, which would take about half the day, I would end up with x to the 6th as my leading term, right? 2 x's here, 4 x's here. So x to the 6th is an even end behavior, which means both up or both down and it will be positive this time, right? Since there's no negative out front, which means my end behavior should both be up, which knocks out B, because B is both down, and it knocks out C. C is 1 up, 1 down. A and D have both end behaviors up. So since we're looking at factors, right? This is written out in factored form. I can look and tell what the x-intercepts should be. They should be positive 3 from the first factor and negative 1 from the second factor. So let's see, positive 3 and negative 1. Look at A. Where are A's? Well, here's positive 3 is right here. Negative 1 is right here. It looks like they do the opposite. It looks like they cross at negative 3 and positive 1. And it should be positive 3 and negative 1. So let's just go and make sure that our D does what it's supposed to do. Is it crossing or touching at negative 1 and positive 3? Here's my positive 3. Yes. And here's my negative 1. Yes. So that's why it would be D. The end behavior is both up, and it's got the x-intercepts that are positive 1 and negative 3. All right, last one, number 12. So this one is written out with the group of terms. So I'm not going to try to find the x-intercepts on this one if I don't have to. I can still use in behavior and y-intercept on this one, right? Because it's written out, and if I replaced all those x's with zeros, I just have that 81 at the end. So finding the y-intercept is the easiest thing to do here after in behavior. So let's see. X to the 3rd is a positive odd. So it's not A. A is even, right? They're both up. B starts down, travels up. So that's a positive odd. So B is still in the race. C starts up but travels down. C is out, right? That's negative. D starts down, travels up, so it's still in. So it's either B or D. They both do the same thing. So now let's go to Y-intercept. So remember, if I put zeros in for all these X's, the only thing that's going to be left over is this positive 81. So let's look at B and D and see which one crosses the Y-axis at 81. Well, looking at B, I see it crosses in the positive something, right? If this is 250 up here, that means that each one of these hash marks is 50, right? 50, 100, 150, 200, 250. But look at D. It's going to be pretty easy to tell which one crosses at 81, even if you can't see it exactly. Where does D cross the Y-axis? Crosses it at 0, doesn't it? Right there in the middle. Look at B. Here's the Y-intercept right here, which is in between that 50 and 100 hash mark. And where do we want it to cross the Y-axis? At positive 81, which would be somewhere between that 50 and 100, right? So that's why you would pick B on that one. All right, that's it, right? Yeah. Okay, so on Wednesday, we will cover 8, whatever's next, 8.3. It may be a long one. We'll try to cover it on Wednesday and see what happens, and then we'll see what we can get in on Friday. But we only have 2 sections to cover this week, and we just covered one of them today. So y'all have a good rest of your Monday, and I will see you on Wednesday.